Login accepted.
Okay, it looks like we are ready to start. So first things first, it feels great that all of you decided to sacrifice your lunch to go and hear about the next version of Hazelcast. And the title, Hazelcast 5.2, might sound boring because what this guy could potentially do, probably he will just go, print out all the list of changes and talk about them. And yes, I will do this partially, but the main goal for this presentation today is to introduce you to the revolution that Hazelcast is slowly going through and to give you a sneak peek in something that you can expect potentially in the future. My name is Grzegorz Piwowarek. I work as a lead architect at Hazelcast. No, it doesn't mean I do a lot of PowerPoint presentations. It means I'm working directly with the CTO office and overseeing a few projects, and I have a chance to contribute directly to the product itself. You can also see me around doing consultancies and workshops, and you can find some of my articles on my webpage. It's been a bit neglected due to COVID, but it's slowly getting back on track. So, Hazelcast has been around for a very long time, and it started in the space of caching, right? A simple distributed key value store where you can put some values, take them out. And this is pretty much what most people think about Hazelcast. Most people, when they hear Hazelcast, they think, okay, the Java distributed cache. And that's true, but over recent couple of years, a lot has changed, and Hazelcast is not just a cache anymore. But that's true, that's how it started. A long time ago, it was just a simple caching solution. But over the years, it evolved something called IMDG. So now, if you look up the definition, it's something like an operational in-memory computing platform. That sounds super abstract and super complicated. And to some point, it is. But it provides way more value than simple caching. So a long time ago, we started as a simple cache, but on the side, we were working on Hazelcast Jet. It was quite a complex streaming solution. The interesting part is Hazelcast Jet depended on Hazelcast itself, but we were still trying to sell them as two different products. At some point, we made the realization that, hey, people that are using Jet, they are quite likely using Hazelcast anyway. And we tried combine them into one solution that allows you pretty much to, as we call it, react in real time to data. And especially if you are working on data that's already in Hazelcast, then it means your enrichment, the stream enrichment, is pretty much free. But let's go a step back. What does this IMDG thing mean? In-memory data grid. In-memory means that effectively there is no persistence involved. This is supposed to underline that this thing is fast, but at the same time, it's not supposed to be used as a system of record. So the data you put there, you can potentially lose them under certain conditions, but you trade it off for extra speed and lower latency that you can leverage for different things. However, nowadays we can notice that modern storages are getting faster and faster, so it's quite possible that this in-memory in Hazelcast will remain just as the hot cache eventually. Data. Well, as you can imagine, that data means that we are storing data. But many people are not realizing that there is also a computational layer to that. Because when you store data, and let's say you want to process them, that's where you get to experience the whole power. But you might be thinking, if I want to process my whole data in a cluster, you could get the map, you could iterate with this data and put them back. Well, guess what? This won't really work. Because if your cluster is really huge, that's not really a valuable thing. Because there's another thing. Grid means that we are effectively combining multiple nodes that work together, forming one cohesive entity. So you might be thinking, when you are interacting with that, it feels like you are working with a single map that's continuous. But what's actually happening underneath? Data is partitioned and distributed around the whole cluster. So if your cluster has 200 nodes, each 100 gigabytes, and you want to do a for each on all of them in your application, that might not work. You might run out of RAM, and it might be long, and it might not work at all. Where is the best place where you would like to perform computation on data? Each member that has the data should be able to perform computation on them. And that's what the compute effectively means. And this is where the fun begins. So we took all of that, and we added that layer of stream processing into that. And as you can see, this is a pretty enterprisey presentation of how these things work. But to give you some intuition about how this could look like, imagine you are developing, you want to enable certain business opportunities within telecom space. And this is actually history from a project that we've done some time ago. Imagine you are analyzing how your SIM cards connect to which BTS stations. Those are those towers where pretty much they just transmit the GSM data. You're analyzing in real time what's happening. And you start noticing patterns. And the pattern is that someone is getting closer to the border. And if that person is getting closer to the border, well, there's a huge chance that they procrastinated and never got the roaming package. So immediately identify that and send a message with a direct offer tailored for them. Another use case, think about companies like Allegro. Let's say you are putting stuff to your basket, and you can analyze in real time what's happening and then issue some action based on what user did immediately. You could do that with batching, but the point of that is you need to react really, really fast. So if you are not notice certain pattern of what customer is putting to a basket, and you can see that person is trying to leave or thinking too much, you can suddenly push them or send them a message to do something to make them remember about that. And this is where the power of real-time is noticeable. So the Hazelcast itself is available also as a cloud platform. So if you want to have Hazelcast in this new offering, you can find it in the cloud. However, that's just Hazelcast in the cloud, literally. But we have some newer ideas. But let's go to the core of this very short presentation. So the biggest change that's happening in Hazelcast is that for many years it was Java-oriented. It was Java first. But nowadays, when Hazelcast is no longer just a cache, it's no longer just a Java library that's no longer used just as embedded mode in Java, it makes sense to go polyglot first and start simplifying things. So let's say you want to perform some computation on data that's in your cluster. Normally, in order to do that, you would need to implement your own interface, our interface, and provide your own implementation, for example, entry processor. And guess what? Imagine you have a Python developer or a Golang developer. They would like to do all of that. I can't imagine really them implementing all of that by themselves. So going polyglot first is a huge direction with a huge bet we are taking, which means, for example, that we will be getting rid of all that custom code implementation that you need to do. For example, if you wanted to store custom Java classes and make it efficient, you would need to implement your own serializers and deserializers. That's a lot of boilerplate code, which is annoying, and you still need to deal with potential class loading issues because you need to upload that code. So in 5.2, you will have the first release of the zero config serialization, which means that regardless of what developer you are, Golang, Python, .NET, Java, you can just use your classes, and with zero config, they will be serialized in an optimal way. The schema will be derived from your object and stored in the cluster itself. And that's a huge thing, because it removes quite a lot of hassle. And if you've been working with Hazelcast before and thinking, oh, damn, not again those serializers, no, it's not there anymore, because you can use a better and faster serialization option. Another thing is, so far, pretty much we've had normal clients that use binary protocol. Those were Java, .NET, Scala, Python, Golang. But nowadays, there is a better way of interacting with the cluster, especially for people that are not that technical, and there is SQL. So we've implemented an SQL engine, which also supports joining and combining streaming sources. So even if there is so you can represent a stream as an SQL table and make joins on top of that. So if you want to be language agnostic, that's probably the easiest possible way. What's more, in the future, SQL Engine will allow you to get rid of entry processors, quite a lot of code upload, and define it at the SQL level. What's more, in Hazelcast, it's quite common that you need to pull some data from some other data source and keep it there for the sake of processing. And you can do it manually at the application level, write the code which takes it from a database, for example, puts it in Hazelcast, but that's kind of brittle. And in ideal scenario, you'd let Hazelcast pull the data on its own from a database or other data source. In order to do that, guess what? You need to implement another interface, map loader or map store. And this is not difficult. This is some trivial Java code, but guess what? Again, it's hard to expect Python people to write trivial Java code, boilerplate Java code, to make such simple stuff work. So we are shipping a new zero-code map loader, which is a generic map loader, which allows you pretty much it works for MySQL and SQL sources. You provide just configuration data, and it will automatically pull the data from tables for you. And SQL works pretty much as as any other SQL. There are some differences from the standards, but that's kind of common nowadays. Another thing that we introduced is that since you are keeping all the data in Hazelcast and you want to react to changes happening on that, in Hazelcast we've had already a change data capture connector for JET. So for example, if you wanted to observe changes happening in some database and react to events, you could do that. But it was a bit weird that you couldn't do that for Hazelcast itself. So if there are changes happening in the map of Hazelcast, you couldn't really listen to events in a comfortable way. So we've shipped, and we are shipping another change data capture for the IMAP itself, which means you can convert IMAP changes to a stream of data on which you can react in real time. And finally, the biggest change that's not yet to be released, but will be released this year, is our serverless offering. So I told you already that we have the Hazelcast Cloud offering, but that's just literally Hazelcast in the cloud managed by us. And in order to be successful with that, you need to know what you are doing. You need to understand how Hazelcast works, because when you are setting up your cluster, you need to answer a couple of questions. You need to think about how many members do I need? What's the CPU to memory ratio? What's the size of each member? How many backups of partitions do I want to have? Do I want to have async partitions or sync partitions? Do I want to have persistence or not? And so on and so on. And in order to have it work in a really good way, well, you need to understand what does it actually mean. Serverless offering, the idea of serverless offering is to abstract it all away from you. So the idea is to provide a new product based on the Hazelcast Cloud, which removes all that operational complexity for you, so that your only concern is your data. And that's what you will be paying for, essentially. No members, no machine types, no cloud, just the amount of data that you pipe through Hazelcast itself. It will be slightly opinionated. It will be focusing on developer experience. So imagine that you actually still need to upload some code to Hazelcast itself. You open a console, you download a sample project, which has a Maven plugin, you copy-paste some code to the already placeholder with, let's say, entry processor, and you click and you push Maven deploy. And it goes directly to your cluster almost without you just need to provide your API key and secret to your cluster, and it's deployed right away. And logs are streamed directly to your console. So this is heavily developer experience focused, and the beta will be available in this year already. If you want to learn a bit more and see what you can potentially do with Hazelcast Jet, there is a separate repository for that. If you want to learn how it works internally, we are going public with almost all the design documents. So you can, even if you don't want to use that, you can learn how it works and probably become better engineers as a result of that. There is a white paper on that. And that's all what I wanted to tell you today. So I hope you learned something new. And we don't have time for questions, but I will be around, so feel free to catch me right away. Thank you.